small, but it looks like a 4 to me. Well, you're looking at y's, I think.
Oh,
And we're integrating dx.
Oh, we are.
That's okay. And then what else do I need to do? We need to change our y's in terms of x. So what would we put in for y sub 1? Is it the f of x function or the g of x function? The curve is actually square root of x, isn't it? The top equation is the square root of x, so that would be the entire radius. So we're going to do square root of x squared minus y sub 2 would be represented by 0.5x. And we're going to square that dx. And then again, I'm going to have you guys actually compute that for sake of time. Okay, last example. This will also be on the AP exam. Sometimes it's on the multiple choice section, but a lot of times it's on the free response section. And so this one says the base of a solid is given by x squared plus y squared equals 4. Each slice of the solid perpendicular to the x-axis is a square. Find the volume of a solid. I want to show you some examples. Of what this might look like. First of all, tell me what the graph of x squared plus y squared equals 4 looks like. It's a circle centered at the origin with radius 2. X squared plus y squared equals radius squared. Circle centered at the origin, in this case the radius is 2. It says each slice of the solid perpendicular to the x-axis is a square, and then find the volume of the solid. What you're going to do to solve this problem is instead of the disc or the washer method, you're going to pay attention to the shape. In this case, the square, because sometimes it'll say each slice perpendicular to the x-axis is a triangle or a rectangle or different geometric shapes. You're going to pay attention to whatever shape that you're given, and you're going to integrate the area formula for that particular shape. Okay? Technically integrating volume, but your h is dx or dy. Okay? So in this case, what's the area formula for a square? S squared. Right. So you're just integrating s squared. And since it's perpendicular to the x-axis, we're integrating with respect to x. If it were perpendicular to the y-axis, we would do dy and so on. Here is an example of a solid which is formed with the slices are triangles in this one. Okay? So in this case, what's the area of a triangle formula? 1/2 base times height. We would integrate 1/2 base times height to do this one. And I'm just going to pass it around so y'all can look at it. Actually, shoot, I picked two triangles. This one is a rectangle. It's a solid formed with the slices are rectangles, and the shape will not always be a circle, by the way. But in these two examples that I've pulled, they're both circles. And so the slices are, in this case, there are rectangles. And what you're doing is you're finding the volume of that solid. Okay, so here's what I want you to write down in your notes while you're passing those around. I want you to write down that if you see a problem like this, a lot of times you'll see the words cross-section. So if you see a problem set up like this, or if you see the words cross-section, what you're going to do is you're going to integrate the area formula for the shape that is given. So in this case, a square was given. Sometimes it'll be a rectangle, sometimes it'll be a triangle. Whatever shape they give you, you're going to integrate the area formula for that shape. And so for this example, let's do that. Let's say that volume is the integral. Will I have a pi out front? No, because there is no pi in the area formula for a square. The reason we have a pi in the disk and the washer method is because we were integrating the volume of a disk, or a cylinder, so to speak. So there's no pi in this one. We're just integrating what we're calling s squared. And we're integrating with respect to x, since it says x perpendicular to the x-axis. If it said perpendicular to the y-axis, we do dy. So let's look at a visual real quick. Circle, radius we said was 2. The slice is perpendicular to the x-axis, so it's going to look like this, or like this. I can pick any slice, or like this. Any slice perpendicular to the x-axis. And so what we need to do is we need to come up with an expression for that length. Okay? Well, if you think about it, the equation we said was x squared plus y squared equals 4. But if we were going to graph this, like think about graphing it on the calculator, you'd have to solve for y to graph a circle on the calculator. You would get y by itself. Y equals plus or minus the square root of 4 minus x squared. Do you remember that the positive square root gives you the top half of the circle, and the negative square root gives you the bottom half of the circle? So this top piece is going to be the positive square root of 4 minus x squared. And then the bottom piece down here is the negative square root of 4 minus x squared. Can you come up with an expression for that piece? One slice perpendicular to the x-axis using those functions. What would we need to do? Well, let's think about it. How long is this one here? It's 4, isn't it? 2 minus a negative 2. Like 2 minus negative 2 is 4, because it's 2 plus 2. So if I wanted, let's say this is at 1, how long would this piece be? It'd be 2. Because it'd be 1 minus a negative 1, which is 2. You can think of it that way, or you can think about it as just doubling the y value, right? The top y value anyway. If you picked x equals a half, then it's going to be 1. The length of that side of the square there is going to be 1. Are you following me? So you can think of it two ways. You can take the top equation minus the bottom equation, because it's going to be square root minus the negative. Or you could just think of 2 times the top equation will give you the length of the side. What are the bounds, by the way? -2 to +2. Good. So it's going to be -2 to +2, and then it's going to be 2 times the square root of 4 minus x squared squared. Now, like I said, you could do square root of 4 minus x squared minus a negative square root of 4 minus x squared, but minus the negative is just plus. That's going to give you 2 of them. And then I'm going to have you guys integrate that and give me an answer. You can use your calculator, that's fine. You don't have to do it by hand. Okay, and then for tonight, I would like for you to there it is, page 428, 1 through 12. Page 428, number 1 through 12. Homework for tonight. Before I forget, tomorrow we may have a visitor during this period. Just to let you know, her name is Ms. Morton. She's coming from Advanced Kentucky. You know, the grant that signs your check when you pass the AP exam, your $100 check in your pocket. Usually they'll do a site visit once or twice a year, and I think she's coming tomorrow. She might be in this class, just so you